Okay. All right. So this is not, this is correct, but this doesn't give you the answer. Okay. So far this is correct. Okay. So this not simplify the problem. So this is the don't simplify the problem. The original integral. Okay. All right. So that's the first example of the integration by parts. Okay. Let's see another thing. Okay. So let's see if I have this one. Okay. So now instead of x, we replace it by x squared. So here, our choice is that the u equals x squared, and the v is this. Okay. Then what we have is that u is 2x dx, v is still same, e to the x. So by part, integration by part, give you u times v. Okay, so x squared e to the x, and subtract this integral. Let's see, what is this? V du. So 2x there. Okay, and this is a correct choice because the integral you get from the right-hand side is simpler than the original integral. The original is x squared here. X squared exponential times. Here you have just x, just linear. So this is power 2, you end up with power 1. Okay. And again, this is by integration by parts. Example 1. So we compute this already. Okay, so we have x squared e to the x minus 2. All right, so let's copy what we have because we compute this here. Okay, so this is exactly. So x e to the x minus e to the x. Oh, let's take the oh, sorry, e to the x. But this one, or you might want to write this down as, let's see, this is a quadratic, so because this x squared, you take the e to the x out, so minus 2x plus 2 e to the x. Okay. So the choice for u and the v is matter. Okay, so it's important. All right. Let's take integral of ln of x. Okay. In this case, since we don't have much choices here. Okay, so we let u equals ln of x. Okay, and dv is just dx. Okay, let's see what happened here. So du is ln of x, so 1 over x, so x over x, and v is just, this is 1, so it's just x. Okay, and by parts, integration by parts give us this one here, u times v. So that's x ln of x. Okay, so subtract integral and see u times u v du. So the x cancel, just the x. All right, so you get another integral, but this is easy. So we have x ln of x minus just x plus c. Okay. Questions so far?
Can you repeat how you determine the v?
V here, just integrate in this this example. This one? From this one,
Okay.
you mean? Just
Yeah.
integral. So for you, you differentiate, okay, take derivative. For the other one, take integrations. Okay.
Wait, sir, can you rewrite the integration by parts formula? I was lagging but when you wrote it down.
Okay. Just this one here. Okay. So u dv, uv minus integral v du. You switch this u dv here.
Okay. For number 2, yeah. Number 2, then why is there a -2 in front of the integral? But -2 x ex, since the v is only ex, why is it not x squared e to the power of x minus integral of ex dx only?
All right. So we have okay. So the choices, okay, right? So we compute the u and v like this, right? So this is u times v. Always cross this one. Cross this one, right? X squared e to the x. Okay, and then this one, this combination, v du. Yes. The u here is the u here is 2x dx, so e to the x. So 2 is actually inside the integral, but take it out, factored it out.
Oh, okay. I get it.
Okay.
Thank you, sir.
Excuse me, Pak.
Uh-huh.
Can you go back to problem number 2?
Example 2, all right.
How do you integrate the integral of x times e to the power of x?
Oh, this one, example 1. We already compute this one.
Oh, okay. Thank you, Pak.
Right. So basically, it is twice integration by parts. Right. So you expect if I put this, replace the x squared by x cubed. Right. So on the right-hand side, first you get x squared e to the x. Right. When you integrate x squared e to the x, you get x integral of x e to the x. And then integration of e to the x. So basically you're doing 3 times integration by parts. Okay, here you're doing twice differentiation by parts. First one, doing first one, let's reduce the power of x, become 1. And another integration by parts, reduce this power 0. Power 0 is constant. This example 1. Okay. So theoretically, you can just mention this one. If you have x with power, say power 10, you're basically doing integration by parts n times. Okay, that's why. Of course, we're not doing with high power. With high power, just use a calculator. Our purpose here is just to understand how to use how to work it out using integration by parts. Okay. All right. Let's see this one out. Okay. So let's u equals x, v is sin x dx. So here du is just dx. The v is just sine, okay, to become cosine dx. Okay. And using by parts, u times v. So u times v sorry. My mistake here. Oh, sorry. Yeah, this is dv. Okay, so v here is just integral of sine, this negative cosine x dx. Oh, without the x. Right? So u times v, so minus x cosine, subtract this integral v times du. Cosine, this negative will make this become a plus. Okay. Now integral cosine is just the elementary integral. So this one you look up at the table on the table. In the table, the cosine is just sine. There.
Excuse me, sir, I have a question.
Uh-huh.
In choosing the U, should we use the Liate method, LIATE method?
What method? The
Log inverse, algebraic, trigonometry, and exponential in determining the U.
Not necessarily. Not necessarily. Forgot what the rule at the moment. Okay, so you'll
Yeah.
see the choice for this. Okay, so if you let's see what happened if you choose differently. So here, what happened if I choose u equals sine and the v is just the rest, so x dx. So then what we have is just integral sine, just negative cosine. Sorry, du is just x dx, and v is just 1/2 x squared. You integrate. Okay. So by parts, you get u times v. That's like x. And here you have the v du. So 1/2 x squared. Again, this is more complicated than the original integral. Why? Because, well, sine and cosine is basically the same trig functions. Same in that level of difficulty. Right? The thing is, this is x squared. So this is more complicated than the first integral. The original. Okay, so this doesn't work. So this is not a good choice. This one works. Another example. Okay, so all right. So from this example, you see that the choice for u and v matters. Okay. So wrong, not a wrong, say as the wrong answer, but the another option might give you a more complicated integral. Okay, so let's do this one here. Integral, say this is sine x times cosine x. And here I would like to use integration by parts. Okay, this can be done using using other method, but integration by parts. I would like to show you something here. Okay, so that u equals, well, did I choose sine or cosine? So let's just try it out. And the rest is dv. Okay. Then what we have is just du is cosine x dx, and v equals integral cosines negative sine. Sorry, sine cos just sine. Okay. So integration by parts. See what you get here. U times v. Sine square. Okay. And then integral of v du. Well, but this gives you another. Well, you see, we start with this integral and you get this integral back. Right? Let's see what we are doing here. But the thing here, because this is the same, so you can put this, let's move this out to right-hand side. If you move this to right-hand side, you get two of them. Okay, so this equals to okay. Okay, So then just 1/2 times A plus C. Okay.
Excuse me, Pak.
Mhm.
Where did you get the 2?
The 2, because I moved this out to the left hand side. They are the same, right?
It's supposed to be just the integral of sine x times cos x dx, Pak.
Yes. You see v du, right? Integral of sine x cosine of x dx. Same thing. So we start with integral sine x cosine x. We end up with exactly the same thing. But see, this is with a different sign. So you can move this to the right-hand side, right? So in fact, this negative signs is where our luck comes from. Okay. Should this be the positive? Let's see. If this positive, then the left-hand side and this integral cancel out, and you end up with sine square x equals 0. Okay, so you don't get anything, get nothing out of this. Okay.
Okay.
So the fact that this is negative, you can move this out to the left-hand side and make it 2. Twice of this integral.
Okay, Pak. Thank you, Pak.
Okay. All right. So let's do another thing. Still same problem. You might wonder why do I choose sine x, not cosine as u. So let's do this. Cosine x is okay. So du here is just negative sine x. Here phi is integral sine, so integral of sine, negative cosine. Okay, so by integration by parts, you see that's u times v, so negative cosine square x, right? And let's see, v du, negative integral. So this negative become positive, so this will remain subtraction. So this is sine cosine. Okay, but we have negative sign here, so you again put this back twice of this. Left-hand side. That's equals to okay. So here in the end it's just negative 1/2 plus c. I put this c back here. See. But why we get cosine square? Here we get sine square. Okay. And you see, there is another way. Let's see. Let's use some trigonometric trig identity. Sine x cosine x is just 1/2 of, say, this is sine cosine. Correct? Sine 2x is just sine x. Yeah, because this is x plus x, right? So let's see, what is, are you familiar with this formula? Trig identity? We usually have this one. Sine 2x is just 2 sine x cosine x, right? But we start with sine x times cosine x. So 1/2. Okay. Using this identity, we have, so this is not integration by parts. So we have 1/2. Okay. And this is 1/2. Sine of integral of sine is negative cosine, but this is another 1/2. So this gives you negative 1/4. Okay, so you get 3 different answers from just one problem. Okay, so say this is A, this is B, and here we have C. Sorry, C here is not constant, but the index. Okay, what's wrong with this? Are these all correct? Okay, because it seems that we are correctly applying by parts in this integral. Do you see any relations? All right. Okay. Recall how the sine square and cosine square related. So, recall how sine square and cosine square related. What kind of formula you have?
So is it from the identity? Sine squared x plus cos squared x equals 1.
Yes, we have this formula. Okay, so you see that cosine sine square, so whatever you like this, is 1 minus cosine square x. Okay, so you see, if you replace this sine square by cosine square, so this is 1/2 1 minus cosine square. Okay, so from A, C, that equals to 1/2. Okay, so you see this is negative 1/2 plus c of, say this is 1/2. But this is what we call okay. Don't be fooled by this letter C here, constant. Okay, so the constant appears here, the C, this one, and the first one. It's just the same letters, but they may be different. Okay, the value may be different. Okay, so this turns out the C is just C in A plus 1/2. Okay, so basically, so this answer, these are the answer B. Okay, so basically they are the same, just different in a constant. So how about this one, cosine 2x? So from C here, 1/4 cosine 2x. All right. So what is this? Another trig identity gives you, this is cosine square of x minus x plus 3. So this gives you, let's use the is that true? Correct. Cosine 2x is just cosine square minus sine square. Or is that? Oh, that's negative. Sorry, there's a negative here. Okay, so we have. I'll just use this one. All right. Let's replace this by. Okay. So you get how many? Just do this one by one. So this is 1 minus 2. Okay, and this gives you 1/2. Okay, and this is just negative. Again, this is actually A. All right, so it turns out that the seemingly different answer, 3 different answers, is basically are the same. The distinction is just a constant. Okay. Same, except for a different constant. Okay. So don't be fooled by this letter C, constant. They may appear rather differently. Okay. Questions? All right, let's stop here for 5 minutes and then continue with some more example and then another method. Okay.